Hello everyone. So in this video we are going to do this question, and this question is from calculus, in particular limit chapter. The question says that fn, and fn is a function of n defined by 1 minus 4 sine squared pi by 3 into 2 to the power n, and the tk is the product of this function value over n, and n runs from 2 to k. So we have to find out the limit k approaches infinity 4 by tk. So basically what we have to do, we have to simply substitute the value of tk and find the limit of the tk when k approaches infinity. This 4 is just given to get the answer at a numerical integer. So if we are successful to find out the tk in a simpler version or the simpler expression, then we can find the limit of the tk and when k tends to infinity, and then that value will substitute over here and we get the answer. So before jump to the solution, I suggest you to pause the video and give an attempt to the question. And if you attempt it correctly, your answer should be 6. So let's now jump to the solution, and what the solution I'm going to present here by using the trigonometric identities. So there are two important things, that how do we convert this fn in a simpler way, so that further I can write the tk as a telescopic in the form of product. So let's see it here. So for that, what we can do, we are going to use the cosine 3 theta formula. So what we know, that is cosine 3 theta is 4 cosine cube theta minus 3 cosine theta. From there I am taking this cosine theta common, so we get cosine theta as 4 cosine square theta minus 3. And why it is so? Because now I can convert this cosine square theta into sine square theta, and it is going to be in the form of this one. So this is going to be cosine theta, then 4 times 1 minus sine square theta minus 3. This will turn into cosine theta, and you can notice that will become 1 minus 4 sine square theta. It means from this identity I can write 1 minus 4 sine square theta as cosine 3 theta divided by cosine theta. Now, since I have the angle over here in terms of n, and for each n we have to evaluate some values technically, so what we can do, that we assume this theta n, let us say theta n is pi by 3 into 2 to the power n. So I can write 1 minus 4 sine squared theta n is equal to cosine 3 theta n divided by cosine theta n. But still we can see, for the product what I need in this format, I need this vk over vk minus 1, or I can also say that it's a vk into vk minus 1, and so on, so that we can cancel out some numerator and denominator to left out with some nice values, and from there we can evaluate the limit of. So this is not so far in the clearer version where we can go for this product telescopic. So for that we have to manipulate this expression further. So I'm going to write again here 1 minus 4 sine squared theta n, that is equal to cosine 3 theta n divided by cosine theta n. Now, can we convert this thing in the form of sine so that we can use it easily? For that, there is one hint. What the hint is, whatever zoomed here is a theta n, let's try to go deeper in thinking on this theta n. Suppose I want to write theta n minus 1. So, of course, on the right hand side, I have to substitute this n with n minus 1. So, what we get it here? 3 times 2 to the power n minus 1. And further, when we simplify, we get 2 times pi by 3 into 2 to the power n. Now, notice what is happening, that theta n minus 1 is nothing but twice of the theta n. And this is going to help us. How it will help? Let's see. We know that this cosine 3 theta n can be seen in the formula of sine 6 theta. What I mean to say, that if I take the sine 6 theta n, I can write 2 sine 3 theta n into cos 3 theta n. It means I can write this cos 3 theta n as sine 6 theta n divided by 2 sine 3 theta n. And here I am going to substitute this value over this place here. Similarly, I can write the cosine theta n as sine 2 theta n divided by 2 sine theta n. And by substituting these two values over the place of denominator and numerator respectively, what I achieve for the 1 minus 4 sine squared theta n is like this. It is going to be sine 6 theta n divided by 2 sine 3 theta n. And remember, we are dividing this entire expression with this cosine theta n, this one. So when we divide it, the numerator of this will remain in denominator now. So sine 2 theta n, and this will go with the numerator, 2 sine theta n. So 2 and 2 will get cancelled. And what we are going to do is now is a little bit crucial. The thing is that we notice that here there is a 6 theta n and there is a sine 3 theta n. How we can simplify? How do we use this fact here? Let's see it. Notice over here that if I want to remove this 6, I can use this definition. Theta n is theta n minus 1 by 2. So that this 2 will come in denominator and this will cancel the 6 to get 3. And here I am not going to use this thing. I'm just keeping this theta n as theta n. So let me show you what I mean to say. That here I am writing 6. At the place of theta n, I am writing this theta n minus 1 by 2. And in denominator, I am not going to disturb this thing. It's a sine 3 theta n. And here also, I want to write this 2 theta n directly. I can write as theta n minus 1. So what I get here, sine theta n, and this 2 theta n I can write sine of theta n minus 1. You can understand here actually also there's a twice of 3 theta n. So twice of theta n I'm going to write as theta n minus 1. So it will turn into 3 theta n minus 1. So this is going to be sine thrice theta n minus 1. And you notice that this sine theta n minus 1 I can write in the denominator of this thing. And here I have sine theta n and divided by sine 3 theta n. Now you can notice this very clearly, that this can be written as the sine of theta n by sine 3 theta n. This is the numerator, and denominator I can write this one. What do you write? The sine of theta n minus 1 divided by sine of 3 theta n minus 1. So if I think on it closely, I am getting that this is some Vk or Vn, or let me write this thing in terms of, basically this question is form of n only, and we have to start the values of n from 2 and go up to k. So let it be only in terms of n. So I can write this as n, Vn, and Vn, and this is Vn minus 1. Let me just be more precise, that the Vn I'm talking about sine theta n by, sine theta n by sine 3 theta n, and the Vn minus 1, of course we are substituting n with n minus 1, so we get the denominator what we are seeing here. So in this way what we are going to do, we are multiplying this tk, because you see what we have to find, this tk we have to evaluate by multiplying this thing. So Fn what we got is this one, because Fn was this 1 minus 4 sine square theta n, you can see that, and the theta n value already we have assumed it. So after simplification we are going to substitute this thing, we have to keep in mind. So far we got this thing, and we are now in the situation to evaluate this one. So product n goes from 2 to k, and this is going to be f of n. Now let's evaluate it in terms of Vn only, and at the last we are going to substitute whatever left out. So let's see, it means this is going to be the product, n goes from 2 to k, and this is Vn divided by Vn minus 1. So if you start plugging the values of n is equal to 2 and goes up to k, what is the first term we get is the V1, 2 by the way, so V2 by V1, then we get V3 by V2, then we get V4 by V3, and so on till Vk by Vk minus 1. And you notice this is the kind of a telescopic in the product form, and you can also realize that this V2 will cancel this one, V3 will cancel this one, so all the cancellation top down from the left to right is cancelled. So what we are left with is this one, Vk by V1, Vk divided by V1. It means our Vk means the value for n is equal to k in this expression. So what is this one? That is the sine of theta n and divided by sine of 3 theta n, and V1 in denominator, so I'm going to write this. So now here we have to substitute the V1 in the reciprocal, V1 by the way. So why not we can find the V1 from here? It means we are going to substitute n is equal to 1 over there. So what we get it is here, the V1 is sine theta 1 divided by sine 3 theta 1. But what was theta n? If you remember, pi by 3 into 2 to the power n. So what is theta 1? Theta 1 is pi by 6, and 3 theta 1 will turn into pi by 2. It means this is going to be sine pi by 6 by sine pi by 2. So sine pi by 6 is 1 by 2 and sine pi by 2 is 1. So this value of V1 is 1 by 2. But this reciprocal there, so we are going to write 2 there. So 2 times sine of theta n divided by sine of 3 theta n. Now this is the value of the tk. Now we have to evaluate this. By the way, that is tk I have to find, so that should be k there. not n. Here also k, not n. I hope let me write it a little bit clearly. So sine of theta k and divide by sine of 3 theta k. Now we have to evaluate the limit of this. So limit k approaches infinity, and that is going to be tk. It means limit k approaches infinity, twice of sine of theta k was pi by 3 into 2 to the power k, and here sine 3 times pi by 3 into 2 to the power k. So you can see that this 3 and 3 will get cancelled, and what I'm left with is something interesting. What interesting thing is this one? Let's see. This is sine, and you can notice the 1 by 3 times pi by 2 to the power k, and here sine pi by 2 to the power k. Now here we don't have to worry about this limit. We have to just analyze what is going to work there. So see here, when k is approaching towards infinity, the angle of the sine is approaching towards 0, and whenever the angle is approaching towards 0, the sine will approach towards angle. When limit x tends to 0, sine x tends to x. So we can see that this sine will approach to the angle of itself. So that is going to be 1 by 3 pi by 2 to the power k. In denominator also the angle is pi by 2 to the power k. So we are getting 2 by 3 as this limit. But remember, to get the numerical integer, the 4 was present there in the expression. So we have to find out the limit k tends to infinity, 4 by t the k. And here we found the limit of t the k only, means t the k, no, tk of 2 by 3. So what I intended to find is 4 by 2 by 3. So it will be 12 by 2, that is 6. And that was the answer we are looking for. So that's it for today's video. See you in the next video with some other interesting problems, what I think you must try. Stay math active.